Part 3. So I was talking about this angle and that angle. You write this in terms of sine and cosine. Now, everything else is fine because I'm just going to use the addition formula for sine. But this angle, I need to first think about this angle. This angle is 11 pi divided by 6. And I can do it in degrees and then figure out what the angle is, but let me just also help you think in radians. So this is 11 pi over 6. If it was 12 pi over 6, then that would be 2 pi, and in your mind, you know 2 pi means 360. So since it is 11 pi, and you expect 2 pi to be all the way here after having gone a full revolution, right? So 11 pi surely is in this quadrant. So that's the only thing that this is helping me figure out. 11 pi over 6 is in this quadrant. And since this is 2 pi, I hope you can see that the only thing missing from this to go to 12 pi over 6 is the pi over 6. So that acute angle that I'm looking for is pi over 6. Now, that acute angle is pi over 6, but however, the sign in this quadrant of that angle should be negative. Cosine will be positive. So when I go to expand this expression, instead of sine x plus pi over 6, I'll have it's equal to sine, and I'm using this formula for addition. Sine x cosine, instead of 11 pi over 6, I'll just write pi over 6, and I know that it is positive, so I don't need to change the sign, plus cosine, instead of 11 pi over 6, sine x cosine pi over 6, this should be cosine x sine, instead of 11 pi over 6, I will write pi over 6, but I will add a negative because that angle is in that quadrant. So if I'm going this way, it's negative. Or if you think about the quadrant sign being negative, then you still come to the same solution. So have this is equal to the cosine of pi over 6 is pi over 6 is 30. The cosine of 30 is square root 3 divided by 2. And this is negative because this negative comes outside the function, and it makes this positive also a negative. So that will be negative cosine x sine 30 is just a half. So I have my answer being square root 3 over 2 times sine of x minus cosine of x divided by 2. I can write this together as square root 3 sine x minus cosine of x all divided by 2. Moving on, if I want to find the exact value of this whole thing, this whole expression, then I have the tangent of, this is asking me what angle gives me a sine of a half. If the sine inverse of a half was equal to something like a, or yeah, let me use a, then that means that the sine of a is equal to 1/2. So you're asking yourself, what angle gives me a sine of a half? Well, that angle is 30 degrees, or if you want to work in radians, it's pi over 6. And this one, what angle gives me a cosine of a half? That angle is 60 degrees, or if you want to work in radians, pi over 3. So then I'm just going to use the tan addition expression, and I can show you this, the proof for this, if you're interested. Sometime you can ask me. But basically, since sine is sine over cos, it will be sine a plus b over cosine a plus b. If I substitute for the addition formulas of sine and cosine and do some algebra, this is what I'll end up with. So don't look at it and think it's coming from another planet. It's just algebra, and you can do it too, and I can show you if you're interested. So I'm going to use that expression to expand this, or to find the value of this. So this is going to be equal to tangent of the first angle, so pi over 6, plus tangent of the second angle, pi over 3, divided by 1 minus the product of the tangents, the tangent of the first angle times tangent of the second angle. Tangent of 30 degrees is 1 over root 3, 1 divided by root 3. Tangent of 60 degrees is just square root 3 over 1 divided by 1 minus 1 divided by root 3 times square root 3. Okay, so what I'm getting here, and I hope I didn't make any errors, is in the numerator I have 1 divided by square root 3 plus square root 3 divided by this crosses out with that. The 2 root 3 cancel out, and I end up with 1 minus 1, which is a 0, which would mean that this whole expression is undefined or does not exist. The tan of this does not exist. The tan of negative 30 does not exist. Wait, did I make a mistake? Tangent of pi over 6. Pi over 6 is 30. Tan 30 is 1 divided by root 3. Tan 60 is root 3 over 1. Oh, it was negative. Sorry, it should be negative. Yeah. I know, you've been watching me do this wrong this whole time, and you were complaining and complaining, and I wasn't seeing it. Apologies. It was negative, so this should have been positive, and this should be negative. And this is, the top is negative, the bottom is positive. I was using the wrong formula. Positive, negative. Okay. Now we're okay. This will happen to you too, so check yourselves. 1 out of root 3 minus root 3. I mean, you guys are smart, so this probably won't happen to you. So, bye-bye. Divided by 2. This will become 1 minus 3, all divided by root 3, all divided by 2. Let me do that slower. The LCM in the top is square root 3. So square root 3 divided by square root 3 is 1. Square root 3 divided by 1 is square root 3 times square root 3 is 3. And that whole thing is being divided by 2. So basically 1 minus 3 is the negative of 2 divided by square root of 3 times 1 out of 2, which gives you negative 1 divided by square root of 3, which gives you root 3, negative root 3 divided by 3. Okay. Now, I know you're wondering, why didn't I, at this stage, just say 30 minus 60 is negative 30, so tan negative pi over 6, and then from there, jump direct onto this answer. Well, I'll still be right, but where's the fun in that? Also, if you had explicitly been asked to use the tan sum or difference functions, then you'd have to go through this process. Alright, they're asking me to prove that this is equal to what I see there. So to prove, if you're proving, you're always starting with left. No, sorry. Yeah, prove, and because there's two words, prove and show. I think prove means you can start on either side to prove the other side. But when they say show, then you have to start with the left to show that it's equal to the right. So I can start with the left because it seems easier. It seems easier to expand than it is to break this down. Cosine of A minus B is the same thing as cosine of A times cosine of B plus sine of A times sine of B. All of that is being divided by sine of A times sine of B. Man, I'm breaking. So I can break this down because remember, A plus B divided by C is the same thing as A over C plus B over C. So I can break this down and then rewrite it. So this is going to become cosine of A times cosine of B divided by sine of A times sine of B plus sine of A times sine of B divided by the same thing, sine of A times sine of B. Now this is the same thing as that, so it gives me 1. Because I divide the same thing by itself, I get 1. And cosine of A divided by sine of A, I can break this down over here. Cosine of A divided by sine A is cotangent of A, and cosine of B divided by sine B is cotangent of B. So I'll just end up with cotangent of A times cotangent of B, and I have proved that it's equal to what they wanted me to show or prove. Yeah, so this is your homework. Good luck.